Hi everybody, the purpose of this video is to go over question 19 in homework 3.4. This was a question that I wanted to go over in class, but I ran out of time, so this video will hopefully help you through this because this homework is somewhat cryptic and it requires you to do a few things which you might not realize that you can do. So that's why we're here. So let's go through this sucker. A storage tank for butane gas is to be built in the shape of a right circular cylinder with altitude 24 feet. So here's our right circular cylinder with a half sphere attached to each end, which of course that's not included in the altitude measurement. If x represents the radius of each half sphere, what radius should be used to cause the volume of the tank to be 252 pi cubic feet? So here's the tank over here, and notice that we have a right circular cylinder, right there, and of course we have two half spheres right there. As a consequence, the volume of this thing is going to be the volume of both of those half spheres, which is basically just the volume of a sphere, and the volume of a cylinder. Okay, well, the volume of the sphere happens to be 4/3 pi r cubed. There we go. And the volume of a cylinder is equal to the area of this circle right here, which is pi r squared times its altitude, or its height, or in this case I guess we could say its length, which we can call h. Okay, now we know that we want our volume to be 252 pi cubic feet. 252 pi. Okay, well that's going to be equal to 4/3 pi, and our radius is x cubed, plus, and now the altitude or height is 24 feet, 24 pi x squared, because once again, x is our radius. Okay, so notice that each term has a pi in it. So the pi's will actually divide out. So they're gone. Okay, and that will give us 252 is equal to 4/3 x cubed plus 24 x squared. Now, one of the things that we can do is get rid of the fraction primarily by multiplying everything by the reciprocal of 4/3, which would be 3/4. So we're going to multiply this side by 3/4, and we're going to multiply this side by 3/4. It turns out that 252 times 3 divided by 4 is equal to 189. That's going to be equal to 3/4 times 4/3 x cubed, just simply x cubed. 3/4 times 24 is going to be plus 18 x squared. And then finally, we probably want to get this into standard form, which means we want to subtract 189 from both sides, and that would give us x cubed plus 18 x squared minus 189 is equal to 0. Now, first thing is, you are not required to solve this analytically. Okay, you do not need to find some way to find the three zeros. Okay, you are more than welcome to either use a graphing program on the internet like GeoGebra or Desmos, or if you have a TI-84 calculator like this bad boy right here, you can use that. Now, using your calculator, if you wanted to use this calculator, what you would need to do is go up to y equals. All right, and then what you want to do is just basically put in this equation. Now remember, x is our independent variable, and this right here is the button for the independent variable. So you want to click on this. That gives us our x. Now to raise it to the third power, this is our power button, x cubed. Use your cursor to get out of it. Then it's going to be plus 18. You don't need to use the multiplication symbol. Just go right over here to your to your x, which is right there, squared minus 189. Now, if you haven't used your calculator before for quite some time, chances are your window will be at the standard window, which is what this is right here. Basically, it's going to show you where it's going to show you the graph in the range between in the box, which is bounded by -10 and +10 in x, -10 and +10 in y. If it's not that, what you can do is you can click zoom. Z standard will plot the curve in the standard window. Okay, but we're in our standard window. We don't have to do that. We're just going to go to graph. Okay, now, as you can see, we can't see the entire curve. We don't need to see the entire curve. We only need to know where it crosses the x-axis. Now, it crosses the x-axis here, right? So that's one of the zeros, but that's a negative value of x, and we cannot have a negative radius. So that is not one of the answers. It also crosses the x-axis here. Now, one of the things about your solution is it's not going to have much precision. Your solution is either going to be 1, 2, 3, 4, 5, or 6. So since this is actually crossing around x equals to 3, I can tell you right now that our solution is going to be x is equal to 3. So you can use this as an approach to figure out to solve this. If you wanted to, you could just basically test this equation for x equals 1, 2, 3, 4, 5, 6, 7. It's probably about as high as you can go. One of those is going to result in this being equal to 0. That's going to be your answer. Okay, but based upon this, I know I have good confidence that the answer is going to be x is equal to 3. Here is my MML backup. I'm going to put in 3. I'm going to pray to God that I am right. And God answered. And that is how you do this particular problem. I'm going to show you one other thing that you can do. And that is to use GeoGebra. So here we go. I can type in f of x is equal to x cubed plus 18x squared minus 189 Okay, and here's my function. Kind of looks exactly the way it looks in the calculator. And if you want to get a grander look of it, you can zoom out and you can see how it behaves. But that's not what you're looking for. What you're looking for is where it crosses the x-axis, and it crosses right there. Just click on that. It gives you your answer. X is equal to 3. So this is also another way that you can actually graphically figure out where this is equal to 0. But the main point here is that I want to bring out is the fact that you do not need to solve this analytically. You can either solve it any way you want, preferably graphically. You can use your graphing calculator. You can use GeoGebra, or you can or you can evaluate x. You can evaluate this for 1, 2, 3, 4, 5, 6. It's probably as high as you need to go, and you'll eventually find your answer. And as always, if you have any questions, you are more than welcome to contact me. If you are still having difficulty with this, remember, you can click on Get Your Help. You can ask my professor and send it to me, and I will do it again. So that's all I have for this particular video. And once again, if you have any questions, please feel free to contact me. This is Bob Boyle, signing off.